Howdy folks, Mr. Reed here, and welcome to one more question. So we're going to be doing a mild level of topic today. Going to be talking about common factor as it relates to binomial algebraic expressions. So if what you're looking to do is factor some binomials, let's get to it. Alright, so this one's a fairly simple looking one, which is good. It's a good place to start. The idea is that anytime you want to factor a binomial, you're going to have limited options. So binomials are not as interesting factoring as most other things would be that we'll take a look at later on. And so you have a limited number of ways to kind of attack them. One of the first things you should always do under any factoring circumstances is to look for a common factor. Now, we can look for common factors even if we're not looking at an algebraic expression. For instance, if I were to tell you that we had 2 plus 6 inside of a bracket, now I could add the 2 plus 6, but we could also factor out a common factor in this case. And so if I list the factors of 2, it's 1 and 2. If I list the factors of 6, it's 1, 2, 3, and 6. So my common factor there that I said both times is actually the 2. I mean, 1 is not going to be very interesting. So what I'm going to do is I'm going to take the 2 and pull it out to the front as a factor of the bracket that's written next. Next thing I'm going to do is actually take the 2 pieces that I have here and divide them by the factor that I'm pulling out. So in this case, it would be 2 divided by 2 is 1, and 6 divided by 2 is 3. The reason that I do that is because if I were to do this in reverse order, which we may be more comfortable with, depending on what you've learned first, the distributive property for a monomial times a binomial would tell you that you take this 2 and you multiply it into the 1 and you multiply it as well into the 3 with the addition symbol still popping up between them. So we get 2 plus 6, which is exactly what we started with. So this is how we deal with a common factor, even if it was a couple numbers. Now, if it's something a little bit different, I'm going to get to that one in just a moment. I'm going to start out with this one. So what if I had 10x plus, let's go with 4. So 10x plus 4. Now, what I can do in a 10x plus 4 situation is say, well, what are my whole divisors that I can find for 10x and 4? Now, this might look a little overkill, and it is, but I'm going to write down all of the factors of 10x. We could have 1, 2, 5, 10, x, 2x, 5x, and 10x. So I could factor out the x, because x divided by x will give me 1, so it goes in evenly. And I could factor out the number part. So any combination of that stuff is going to give me these 8 factors that we have here. Now, of course, the 4 that I have second, that's going to be a little more limited. That's going to have 1, 2, and 4 as factors. So what we're going to do is we're going to look for the greatest common factor between these 2 terms. Now, I actually don't have a whole lot of options here. It really ends up only being the 2. So since the 2 from here and the 2 from here is the largest shared factor, because the second term doesn't even have any x's, so automatically none of those are going to work out. Also, the number's only 4, so I'm not going to be able to have 5 or 10 go into it evenly. The 2 is all we can have there, so we would take that 2 and we would factor it out to the front. So what I'm going to do is say 10x divided by 2. So 10 divided by 2 is 5, and x divided by no x part would just leave you with the x still. So we get 5x, and then plus 4 divided by the 2 that I factored out would give us 2. Now, as a check, especially since we are just coming from this, if you've been following along with the videos, we can take this monomial, multiply it back in, and say, okay, well, How does this end up working? Well, it's 2 multiplying into the 5 and 2 multiplying into the 2. So we would end up getting 10x plus 4, which is exactly what we started with again, so we're in good shape. This again only really has one common factor. The first example that I did with just numbers also only has one common factor. Next up, I'm going to do the one that's up above me right now, which is 3q minus 5q cubed. So in this particular case, again, if I were to write down all of the factors of the left one, I'd have 1, 3, q, and 3q. On the right part, I'm not going to worry too much about the negative for the time being. I would have 1 and 5, q and 5q, q squared and 5q squared, and q cubed and 5q cubed. Now, that's a lot of kind of weird factors, but if I divided q out, I could pull one of the q's out from q cubed. I could pull 2 of the cubes out from q cubed, which is q squared. I could pull 3 of the cubes out from q cubed, which would just leave me with nothing left. But any of those would technically be options. So I skim through and I say, oh, well, what's the biggest, most robust thing that I have here that's shared? Well, that would just be the q by itself. So that is actually, again, the only common factor that I have. So I can pull that out to the front. Now, I'm doing these a little differently than how I would do them personally. So I don't write out all the factors. I basically look through it piece by piece and ask myself, what's the biggest number part that this has in common? What's the biggest letter part that this has in common? And then I pull that out to the front and do my division. So I guess when I started this video, I was just going to cover that one, but then I started off by doing something a little different, and then now I've done it. I'm going to do one more example just to kind of give you a more full picture of what it is that I mean by factoring by using a common factor. There actually are if there's more than one common factor, technically all those factorings are correct. But what we'll see is actually that if somebody asks you to factor something, it's most likely that you want to pull out the greatest common factor, so the biggest one that is shared. So if I were, as a final kind of like thing that I'm going to show you, going to give us 20x to the 4 plus 15x squared. So I'm going to attack this thing by looking at the number part first. What is the biggest number that goes into 20 and 15? That's going to be 5. So that would be a 5 as my factor. What's the biggest x piece that I can take out? Well, I could take out 1x from both of them. Then I'd have x cubed left and x left. But that means I can take out another x because they both still have x. So that would be x squared that I could take out. And if I did that, we would have 20 divided by 5 gives us 4. X to the 4 divided by x squared gives you x squared. 15 divided by 5 gives us 3. And x squared divided by x squared gives you no x's remaining, so that would be the end of that bracket. If I want to double check that, again, we use distributive property, multiply it back in, and get 5 times 4 is 20. X squared times x squared is x to the 4. Plus 5 times 3 is 15, and x squared times no x's there to multiply with just leaves it as the x squared. So we would get the same thing that we started with, which means that our factoring right here in the middle is good. So that's the idea of being able to pull out a common factor. A word of warning, this does not always work. So just because you have a binomial doesn't mean that you have anything shared between the two terms. Actually, it would be really easy to come up with examples where that wouldn't happen at all. For instance, if I said x plus 7 was my binomial, factor it. So we look and say, well, there's a 1 and a 7, so that doesn't share any number in common other than the 1, and that's not going to be helpful because it just leaves it the same if I factor it out. And then I have the letter x, but there's no letter x in my second term, so it's done. So that can't be factored any further, or at all, I guess, if you want to consider it that way. So not everything can be factored. Just keep that in mind. When you're doing practice from common factoring, you might get into this groove where you're like, wow, this is pretty good. Everything can be done this way. And that is very far from the truth. So we're going to be taking a look at some other methods. But next up, I'm going to be doing trinomial factoring, just common factor again. So if you want to see it done with trinomials, let's go to the next video. If you don't want to do that, like, subscribe, and as always, take care, folks.